Hello and welcome to R&D Mathematics. Today we are going to talk about scientific notations. Now, let's say that you have to write down this number 0.0000000000047, and writing this again and again is going to be a little tedious, right? Is there an easy way of writing down this? Now, keeping that question aside, 10. This is the base that we use in day-to-day life, right? In our number system, this is the base that we use. The reason why this base, well, that's really simple. By the way, pause the video and think about this. Why do we use base 10? Why do you think that people use base 10? Well, the reason is very simple, because you have two hands and you have 10 fingers, right? So people start counting using their fingers, and base 10, that's the reason. Anyway, using base 10, for example, if I write 10 squared, exponents, last video we talked about exponents, this is 100, right? And 10 to the 4th, this is, so 4 zeros, 1 2 3 4, 10,000. What if I write down 10 to the negative 3? That means 1 over 10 to the 3, or 1 over 1000. Oh, this is 0.001, right? Now, 10 to the negative 1, this is 1 over 10, oh, 0.1. 10 to the negative 2, 0.01, like that. Now, using that, we can write this in a very simple way. So this number, see this decimal point, I need to, okay, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I move it to 11 places, I get 4.7 multiplied by 10 to the negative 11. This is an easy way of writing down this number, and we call it the scientific notation. Now, for example, how do we write this guy? Well, this guy, now we don't see any decimal, that means this number 0.0, right? So your decimal, if you don't see decimal, that means the decimal is actually at the very far right end, so 0.0. So you have to take 1, 2, 3, 4, 5. So 8.33756 into 10 to the 5, right? So it goes like writing down very small numbers and writing down very large numbers. If the number is very large, like you get a positive power. If the number is very small, you get a negative power. So that's the idea behind scientific notation, and it's really easy to compute with larger numbers. For example, if you had to multiply using a calculator, let's say, well, you can do that, but in reality you have much larger and much smaller number than this. But this question is equivalent to multiplying 2.736. Why? Because 1 2 3 places, so 10 to the third, that's that number, multiplied by here 1 2 3 4 5 6, so 8.7 multiplied by 10 to the negative 6. Is that right? 1 2 3 4 5 6. Yes. Now all you need to do, multiply these two numbers, right? Using the calculator you can multiply those two numbers, you get some number, and 10 to the negative 3. Why? Because here negative 6, here 3, 10 to the negative 3. And let's quickly, let me multiply using a calculator. 2.7, let me do it, 2.736 times 8.7. Well, you can do it by hand, but now you are getting 23.832. Now, this result is not in the scientific notation. Why? Because the first number is 23. In scientific notation, we write down it in actually this form. Now, let me... So, scientific notation, a number written in scientific notation when it is in this form, A times 10 to the n, where A has to be, or actually the absolute value of A has to be between 1 and 10. So let me go back to the previous page and see this number. So whatever the number, it should be in between 1 and 10, the absolute value of that number between 1 and 10. So here what you can do is, this number is, you can take one place, so 2.380 to 10, right? See, 2.38 multiplied by 10, that's 23.8. So this part is equivalent to this, and now by 10 to the negative 3. So the last result, 10 to the negative 2. That's in scientific notation. Now here, let me explain why this absolute value. For example, but if you had negative 8,000, something like this. In this case, the scientific notation is 8.3735 multiplied by 10 to the negative what? 1, 2, 3. Right? So this number A can be negative, but when you take the absolute value, that has to be sit between 1 and 10. Okay, that's about the scientific notation. Thank you.